So for drawing projections of the object, we require different geometrical entities as we discussed. It may be point, line or plane or solid. Then for drawing the projections or image, we need some reference planes. So there are totally three principal reference planes. One is horizontal plane, which is commonly known as HP. So we can correlate it to the ground. Then another reference plane is vertical plane VP. It is also called as frontal reference plane or FRP. So let us imagine this object. This is in the form of one line, and now we want to observe the image of the object. So when we are looking this object from the front side, and let us imagine that the rays of light are incident on this object, and the image of this object will be observed somewhere here like this. So this can be called as the front view of the object, and naturally the front view of the object is obtained in the VP or vertical plane, that is FRP. Similarly, if you wish to see the object from top side, then once again let us imagine that the rays of light are incident on this object from top side, and will obtain the image of the object in HP. It is called as top view of the object. Similarly, we can imagine the third reference plane, which is called as profile plane. So let us assume that the ground is HP, this particular wall is VP. So the profile plane is located in a position which is perpendicular to both HP as well as VP. So the walls on our left or right can be assumed to be in the form of profile plane. So in that way, if we look this object maybe from left hand side or right hand side, then we can obtain the image of object in the same fashion. Means the rays of light are incident on the object, and will obtain the image maybe on this particular wall or the other wall. So that is nothing but side view. The side view can be obtained in two ways depending upon the position from which the observer is viewing the object. So if you see the object from left side, it is called as left hand side view, or if the observer sees the object from right hand side, it is called as right hand side view. So in total we can say that the combination of different reference planes and the views obtained can be marked as, in horizontal plane or HP, we obtain top view of the object, which is also called as plan of the object. So whenever we see plan of a building, it is actually nothing but the top view of the building. Then in vertical plane VP or FRP, we obtain front view or elevation of the object, and in the profile plane we obtain left hand side view or right hand side view. The other name for the side view is also end view of the object. So this is regarding the basic reference planes. Okay. Now let us imagine the different reference planes and the quadrant systems formed from these planes. So actually in engineering graphics, we want to locate the object, maybe point, line, plane or solid, in the space. So for that purpose, earlier we were using the coordinate systems, that is x-axis, y-axis and z-axis. But in engineering graphics, we are going to locate an object with reference to the reference planes, which are nothing but horizontal plane, vertical plane and profile plane. Okay, so first we will consider the basic concepts regarding the projections. So imagine that this is a horizontal plane, then this horizontal plane will divide the complete space in two parts. So the upper part can be called as above HP, this is the half, and the part which is below HP is nothing but the part that is below HP. So HP divides the space into two parts. Similarly, the vertical plane or VP, if we consider, then it will divide the space into two parts. So the part on your right hand side is called as in front of VP. So this part is in front of VP. And the part on your left hand side is called as behind VP. So this is nothing but the combination of HP and VP. So naturally the combination of HP and VP will divide the space into four quadrants, which are represented here. So this is horizontal plane HP, this is nothing but vertical plane VP, and the intersection of HP and VP, it is in the form of one line. This is called as XY line or reference line. So all the views of the object are drawn with reference to the XY line, hence it is called as reference line. Now as we can see, because of HP and VP, the complete space gets divided into four quadrants. So looking from this side, this is nothing but quadrant 1. So this quadrant 1 can be described as it is above HP and in front of VP. And when we draw the projections of the object, assume it to be situated in the first quadrant. It is called as first angle method of projection. So this is about the first quadrant. The object will be located above HP and in front of VP. Then moving in anti-clockwise direction will come here. This is nothing but the second quadrant. So object in the second quadrant can be described as above HP and behind VP. Similarly, the object in the third quadrant can be described as below HP and behind VP. So here we need to understand that if we imagine that the object is situated in the third quadrant, and if we draw the projections of the object, then we say that we are using third angle method of projection. But as per our syllabus, we are going to prefer the first angle method of projection. And finally, if the object is situated in the first quadrant, it can be described as below HP and in front of VP. So this is regarding the quadrant system. Now let us understand about the projections of the point situated in the first quadrant. So here we consider a point P which is situated in the first quadrant, obviously above HP and in front of VP. Now we want to obtain different views of this object or this particular point P. So observer is seeing this particular point from this side, and now we can say that point P is situated in between the observer and the reference plane. So this is the characteristic of first angle method of projection, that the object is situated in between the observer and the reference plane. Now let us imagine that the rays of light are incident on this point and somewhere here we'll get the view or image of this point P. So this image is called as front view of point P, and it is denoted by P dash. Okay. In some other cases it can also be noted as PF, means image of point P in the frontal plane. So we'll use the notation P dash. So P dash is front view of the point P. Here we need to understand that there is an imaginary line between the object and its front view. So this particular line is called as the projector, or it is also called as projection line. In this case, it is important to note that whatever the method of projection we are using, in this particular case, the projector or projection line is perpendicular to the reference plane. Hence, this type of method is also called as orthographic projections. Ortho means perpendicular, in which the projectors are perpendicular to the reference plane. Then this is about the front view. Now let us imagine that observer is looking towards this point from the top side. So once again there will be some rays of light which will travel towards the reference plane, and finally we can obtain the image or view of this particular point P in the horizontal plane. So as the observer is looking from the top side, this view obtained in HP is called as top view of the point. It is denoted by small p or PH. PH means view of the object obtained in the horizontal plane. That is nothing but PH. So for the sake of simplicity, we will be using notation small p, that is the top view of point P, and P dash will be the front view of point P. Once again, this is the projector which extends from the object or the point up to the reference plane, once again perpendicular to the reference plane. Now here we need to understand that this is a three-dimensional picture in which the vertical plane is something like this and the horizontal plane is like this. So we want to draw, this is a three-dimensional picture, we want to draw these views on a piece of paper or the board, which is a two-dimensional figure. Means the projections available in the three-dimensional format, they should be converted into two-dimensional formats. For that purpose, we have to make some alteration, and in this case, in order to obtain these views on one paper, which is a two-dimensional figure, we imagine that the horizontal plane is rotated in clockwise direction. The horizontal plane is assumed to be rotated in clockwise direction through 90 degrees. So we can imagine after rotation this HP will come somewhere here after rotation of 90 degrees, and obviously point P, which is nothing but the top view obtained in HP, this is small p. So the top view will move somewhere here. So rotation of 90 degrees will shift horizontal plane below XY line, and top view will be carried along with the XY line. So let us imagine the situation after rotation. So now after rotation, HP will be below XY. This part of HP will move above XY. So this is nothing but the final outcome of projections of points. In this case, we understand that XY is the reference line. The reference plane above the XY is VP, in which we obtain front view of the point, which is nothing but P dash as per our notation. Then the reference plane below XY line is HP or horizontal plane, in which we obtain top view of the object. The front view and top view of the point lie on the same projector, and this projector is perpendicular to the reference line. So this is about the first angle method of projection. If you wish to represent this, in the format of projections, how we can show? First, we have to represent the reference line. Then we have to represent a projector which is perpendicular to the reference line. Now, if we imagine about the earlier position of the point here, we can easily understand the distance above HP should be marked above XY line. The distance of the point above HP should be marked above XY line, and the distance of the point in front of VP after rotation, it will go below XY. So if we consider that point P is 20 mm above HP and 25 mm in front of VP. So here, after drawing the XY line and the projector, we should mark distance above HP, above the XY line. Simple to remember, above HP means above XY. So here, take distance of 20 mm above XY line. This is nothing but P dash, front view of point P. Similarly, the distance in front of VP should be marked below XY. So in this case, distance in front of VP is marked below XY, and we will get point P, which is nothing but the top view of point P below XY. Here, one more thing we can understand. This was the first point. Second point, if a point is situated in the first quadrant and in HP, so if the point is situated in HP, then its distance above XY or above HP will be 0. If a point is situated in HP, its distance above HP will be 0, means in terms of projections, P dash will be 0 mm above XY, that is P dash will be on XY. So the second conclusion we have to remember is if a point is situated in HP, it means that front view of point will be on XY, and the third situation we can understand, if a point P is situated in the VP itself. So if the point P is in VP, you are looking from the top side, then the distance of point P in front of VP will be 0 mm, because point is in VP. So distance in front of VP is marked below XY, that is whatever the distance we mark below XY in front of VP is given to be 0. Hence, if a point is situated in VP, this distance will be 0. Ultimately, top view of the point P will be on XY. So the third conclusion we can write, point situated in VP or FRP, it means that top view of the point will be on XY. So this is about the projections of points in the first quadrant. In third quadrant, exactly reverse scenario will be obtained. That is, if we go for third angle method of projection, front view will be below XY and top view will be above XY. But we need to focus on the projections of points in the first quadrant, and these are the outcomes of projections of points.